So here we have a two-way table that has two categorical variables. We have a treatment group. So the first category is they get a placebo, they get a low dosage of echinacea, which is 20%, and they get a high dosage. So those are the three categories. Then we have a second variable, which is we record whether or not the person who gets this treatment either gets a cold or did not get a cold. And so this is a two-way or a contingency table, and this is often how we're going to see these things presented. So let's look at the question here. It says, in the clinical trial of effectiveness of echinacea for preventing colds, the results on the table were obtained. We assume no association, so that's the assumption, that's our null hypothesis, and we're trying to show, again, is there a relationship? That's the purpose of a chi-squared test for independence or test for association. We're trying to see, is there an association? So first step, we have our hypotheses, which as we wrote is always going to be in words. The null always assumes that they are independent, and the alternative assumes that they are dependent, that there is a relationship. So we can just write this out, that getting a cold, so that's the first variable, is independent of their treatment group, or however much echinacea they got. And we're also going to look at the alternative where it's the opposite. So the getting a cold is dependent of getting a treatment group. And these were the observations that we see in each one of these categories. So step 2, this is the chi-squared test for independence. So that's what we're going to perform. Step 3, the requirements are the same, the IRL. L, we need all the expected counts to be larger than 5. I have a feeling they will be, but let's let StatCrunch calculate that for us. And so now let's just move on to step 4, which is the calculations. So first you'll notice that I entered in the actual table, the two-way table, into StatCrunch. And the way I've done it is that the row headings I put into the first column, and the column headings I actually put into the column headings. So it's not on the first row, it's in the headings themselves. So that way here we only have the numbers, the actual summaries of the counts for each category. Next, where we're going to find this is under Stat. And this is where it gets a little bit different. It's not one of these that we can find easily. It's actually under Tables, and this is a contingency table. And again, the table itself is a summary. So unless we actually have a list of cold, no cold, 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 no cold, and placebo, 20%, 60%, 60%, if we have those lists, that's when we would use data. But here we have the table, so it's the actual summary. So how do we do this now is, where are the actual summary values? It's under these three columns, the column headings. So those are the column headings that we're going to select. Now the row variables the row headings are going to be under var 1. So for the row labels, we're going to choose var 1. And the things I like to include here, there's a whole list of stuff. You can put a bunch of them in here, but the ones that I find useful are the expected counts, so that way we can answer step 3 for the large enough, and also the contributions to the chi-squared. Sometimes this is useful for us, is once we see there's an association, we can figure out which one contributed most to that association. So those are the two I will include. And you'll see that the one that's already selected here is a chi-squared test for independence. Don't worry about the other ones. And there we go. Here are the results. So first, it tells us the format of each cell. So the first number in every cell is going to represent the count or the frequency, and those numbers are the ones we entered in. So you'll see 88, 48 matches up with all the numbers we have. The second number in each column represents the expected count. So if we were to calculate those by hand, it would give us the second numbers in here. And we actually see all these expected counts are at least 5, so we know step 3, the conditions is for large enough is satisfied. And then the third number in each column or in each cell represents the contributions to the chi-squared. And so these bottom numbers represent the observed minus expected squared over expected. And if we were to add all those contributions together, it would give us the chi-squared value. Now you'll notice it also gave us the totals in case we need those. So if the totals are ever given to you on the table itself, do not include the totals because it will always include those for you. And then finally, we have our degrees of freedom, which is 2, and the test statistic and p-value. So of course, these are the two that we want to report, 1.761 and 4146 for the p-value. And as always, we can finish this off with a sentence to conclude. So since our p-value is greater than 0.05, we fail to reject H naught. So we have insufficient evidence to show that getting a cold is dependent on how much echinacea you get. And there we go.